Okay, welcome back to the channel. This is part 2 of our differentiation topic, and in this part we will cover the finding maximum and minimum points and also how to use your GC and application questions. So yeah, let's get started. So for the maximum and minimum points, which also we also be talking about points of inflection, they're all considered as stationary points. So the very first step you need to do is to find out where the stationary point is. If you have a graph, that is pretty simple, uh, yeah, you see it, you can kind of see it with your eyes where the stationary points are. But the way to express it is that the derivative of the graph at that point is 0. So basically, in other words, f prime x is 0 at that particular point. So that's the first thing you need to do. Find out where exactly that is. Which x gives you the f prime x equals to 0 in the sense. And once you find out those points, you can then move on to figuring out which one is a maximum point, which one is a minimum point, and which one is an inflection. Of course, if you have a graph already, you can pretty much tell it visually, as once again, you can very much tell which one is a maximum and a minimum point. But if you're not, but since in this case, if you're even doing a test, it means that you don't have the actual graph right in front of you. So there are two options. You can look at it in the GC so that your mind will not be confused. Or if you're not going to be confused anyway, just go straight to doing your first or second derivative test. So what are the first and second derivative tests? Well, the first derivative test is just, you see what's the f prime x before and after the point. So like if you have a maximum point, for example, you know that the graph will be going up and then it will stop there and then it will go back down again, right? It's like a roller coaster, And as it's going up, the gradient will be positive, so it will be f prime x is greater than 0. And at that point it's 0, and afterwards it becomes negative because it's going down. So yeah, so that's how you get a maximum point. Yeah, positive gradient, 0, and negative 0 gradient. And you can just write that down in a table like this, and yeah, that's pretty much how you figure out whether it's a maximum or minimum point. Of course, for the minimum point, it will be negative gradient, and then 0, then positive gradient. And for inflection points, you will not be able to. It would be pretty obvious that it is not a maximum or a minimum point. So usually an inflection point will be both like positive 0 positive or negative 0 negative. And you can kind of conclude it's an inflection point from there because yeah, that's actually how inflection points work. But if you're doing the second derivative test and you cannot really conclusively say that there's an inflection point from the second derivative test. And I will tell you how it works now. So for the second derivative test, as we found out in the previous part, which I told you that if the second derivative is greater than 0, it means that your gradient is increasing, which means that it is going from negative 0 to positive. Doesn't that make sense? And where do we see this happening? In the minimum point. And likewise, if your second derivative is lesser than 0, it means it's going from positive gradient to 0 to negative gradient. And where's that happening? On the maximum point. And if your second derivative is 0 itself, well, you're likely dealing with an inflection point, but we can never tell because, well, it just means that there's no change in gradient. That sounds weird. Okay, so yeah, just deal with that, I guess. So if you have an inflection point, or if you already know beforehand there's an inflection point, then don't use the second derivative test, use the first derivative test. But if it is a maximum or minimum point and you want to just get things done quickly and not draw a table, then go straight away to a second derivative test, especially if it's very easy to get the second derivative of the function. Like if it's something like what? It's like some very easy thing to do differentiation on, then you can go ahead and go to the second derivative test. But if your function is so annoying that already deriving it once is annoying AF, sorry, just very very annoying, I hope this doesn't become a problem. Oops. Sorry. Okay, so if your function is very complicated and it takes you forever to differentiate, then don't bother with the second differentiation unless you're hardcore and need to do it. I don't know. Or if you have a lot of time on your hands. I mean, I'm pretty sure there are some people who have a lot of time on their hands. Yeah. Even in the exam, there are some people who are like that. Okay, cool. Yeah, so if you have a lot of time, you can do that. Or if it's very easy to do, then you do the second derivative. If not, just go with the first one. It's simple enough. Um, okay, so the next thing I will be talking about is the more important stuff, which is the application. Oh, sorry, before that, I'll go through the GC. Otherwise, I'll forget about it and then I'll not talk about it and it'll become a problem. So, yeah. Okay, so using a GC to do differentiation. That sounds perfect, right? I mean, you don't need to write anything. You just like, okay, type some stuff in the GC and get your answer. But as you know, I'm not particularly someone who is very fond of using GCs because my GC was quite old and it almost died before my exam. So yeah, please don't over rely on your GC. But if the question asks you to use your GC or if the expression is so like out of this world that you need to actually use your GC, then go ahead and use it. I have nothing against that. So how do you use your GC to find your d or dx? Basically just type your function first, or you can use this function that allows you to go directly to a derivative calculator and you type your function and it should graph it out or something. Or you can type the function beforehand, it will graph the actual thing, and you can use an option that allows you to graph the derivative of that curve. Yeah, so from there you can find out your derivative curve or sometimes even the actual derivative function in the sense. Actually, no, I don't think you can really get the function itself. But you can get what are the minimum and maximum points or certain aspects of the derivative curve from the function, I guess. And of course you can't really get the function itself, but you can get a value of the derivative function using the calculator. So when you're typing out, if you use a specialized derivative function calculator, you can type out which point you want to calculate and you'll get the value of the derivative of that point, of that function at a particular x value. And you don't need to write anything down except using a GC, this is equal to this. I think you guys are clever enough to know how to do this because I don't think my GC is even used in the syllabus anymore. It's very old, so yeah, maybe if you really need it, I can try to borrow someone's GC, newer one and then demonstrate it to you. Hopefully that would, but I think you should know how to do it. If you're unsure, just ask your teacher or your friends who are more savvy with these GCs, I suppose. And yeah, let's move on to the next thing because that is even more important than the GC, I guess. And that is how to tackle application questions, because from experience I tend to mess up in application questions because, well, they're application questions. If you don't do it properly, you'll just mess up. Okay, so the first kind of question will be just asking you what's your local maxima and your local minima. I think that's pretty simple. You just do the usual d or dx equals to 0, blah blah blah. That's your first and second derivative test. You can do all that without any issue. And if it's something complicated, just use your GC to figure out which one is the maxima and the minima. Okay, so the more common application question would be the connected rates of change problems, which is what is written there in the syllabus. So I don't know, that's just how they wrote it. But I think it's pretty, I think as clear as it can get, because connected rate of change means what? The chain rule, of course, because it's connected, right? Yeah, okay. So usually the question will ask you to maybe something to do the area and a volume or something like that. and there'll be another term that will actually be related to another variable. Like for example, the height is 3.5 times the radius or something like that. You can figure that ratio out by either looking at the diagram and calculating it yourself, or they may actually mention it in the question. So let's use that ratio, and it will always be the same ratio, because let's say if you have a cone, even if you cut off the top part of the cone, the ratio is going to be the same. It's just be a smaller number for each of them. And yeah, okay, so that's for that part. And once you have your all your ratios and everything in place, you can just write down an equation. So you can, for example, write down a function. Maybe the volume is equals to this, the usual volume function. You should definitely go and memorize your volume of your cone and your sphere and everything, just in, because I don't remember it being in MF 26. Wait, I can't stop properly now. But yeah, you may not actually find it there, so just remember the formula just in case. I think the most common ones will be the sphere, cylinder, and cone. Those are three of them that you must remember. And if you don't remember, I can 4/3 pi r cube. And for our cone, it is 2/3 pi r square height. Yeah, I think that's how it is. If I'm not correct, just correct me. Sorry, I'm just telling this out of nowhere without even looking at the internet. Okay, it's cool. Yeah, so once you know all these formulas, you can just write it down. Or if they provide you a formula, then great, just use that and write it down. And from there, you can see what the relationship between the different variables. And you can, if there'll be probably three different variables, so it can be something like dv or dh equals to dv or dA times dA or dh, and you'll have to find out the change of one of them. So actually it's not really like this, but more like with regards to time lah. So it might be something like dA or dH, sorry, dA or dt is equals to dA or dH times dH over dt. So this is your chain rule, and from there, depending on which one you need to find, you'll be able to input the others as known variables, and the last one will be the thing that you find. And I think that's pretty straightforward, and it shouldn't be an issue. And from these questions, when they ask you, oh, like how do you how to use the material most efficiently or something like that, usually it's either maxima or minima problem, so you just need to interpret it in correctly and answer the question properly. And actually, if you do that properly, it isn't hard at all. It's pretty easy, and you should be able to do it at a decent pace of fast, right? No, at a decent pace. Yeah. Yeah, so I think we are done with that. I don't think there's anything else to cover actually. I somehow managed to cover all of differentiation in like probably 40 minutes worth of stuff. Okay, so I hope you enjoyed the two parts and you actually learned some stuff from it. If you want me to cover anything like the first principles or something in greater detail, I can do that, but please do comment below. And someone commented that they wanted a physics series. I will try to bring it to you as soon as I can, because I am not free yet. So yeah, I hope you're looking forward to that too. So once again, if you have questions, and you can put it in the comments or ask me in Reddit. And with that, I'd like to ask you to subscribe and press the like button if you found this video useful. And with that, I would like to say thank you and bye.